So today we are going to discuss joiner transformation in Informatica. As we discussed in our earlier lectures, joiner transformation is an active as well as a connected transformation. Why it is active?
Uh, because it's sort out the row.
No. We are not talking about sorter transformation. We are talking about joiner transformation. What is the definition of an active transformation? The transformation which changes the number of rows passing through it,
Rows is
the
yes.
transaction boundary, of the rows passing through it, or the row type.
Uh-huh.
So in joiner we are changing the number of rows which are passing through it. Based on our joining condition, whatever rows will get satisfied will only pass through it. Okay.
Mm-hmm.
So that's why joiner is a active transformation. And can we call joiner without connecting it to the sources? Not possible. So
No.
joiner is a connected transformation as well. Now joiner can be used to join two heterogeneous forces. What if the forces are homogeneous? Can we use joiner to join two homogeneous forces? The answer is yes, we can use joiner in order to join two homogeneous forces also. But in that case, joining those homogeneous forces inside force qualifier will be preferred. So the joiner transformation joins forces based on a condition that matches one or more pair of columns between these two forces, okay?
Okay.
So write this down that joiner transformation is active and connected. It joins the forces based on condition that matches one or more pair of columns between two forces that we specified.
Okay.
Now one of those input pipelines will be called master and another will be called detail.
Detail. Yes.
What if we need to join more than two forces? Then we will use multiple joiners. The result of one joiner will act as input to the another joiners. What if we need to
So
join, what if, for an example, what if we need to join three tables A, B, and C? Then in first joiner, we'll join table A and B. The result, let's call it AB, will join with table C in another joiner. Okay?
okay.
So just like I said, if we'll have more than two forces, in that case, we will have to use multiple joiners. In this scenario, we have three sources. So what we'll do, we'll choose the sources which will minimize the amount of data passing through it. So let's say A and B are chosen. We'll join A and B first, and the output of A and B will be joined with the output of first qualifier C later on, and that will result in output of joining A, B, and C, and that will be our final output. So in
Okay.
this case, we had three tables to join. In order to join three sources, we had to use two joiners. What if we had five sources? Then we would have needed four joiners.
Four joiners. Yes.
So what if we had n number of sources? Then we would have needed n minus one joiners. Okay.
Okay.
So in order to join more than two sources, we'll need to join the output of joiner transformation with another source. Similarly, to join n number of forces in a mapping, we'll need n minus one joiner transformations. Okay.
Okay. But I
Now,
have one question.
yes, go ahead.
Can I ask one question? Okay. So, for example,
So your question was that how do we choose the master and detail when we are
uh-huh.
using a joiner? So we'll be discussing it later. We'll be
Okay.
choosing the master table as the table which is having the highest
Let's.
cardinality and the lowest number of records. We'll discuss this in detail.
Okay.
First of all, write down the steps of creating a joiner transformation. They are as similar as creating any transformation. We'll go to the transformation tab. We'll go to mapping
Mm-hmm.
designer, then transformation tab. Then we'll create the transformation, name the join in transformation, and click OK. We'll drag the ports from first force. We'll take the ports from second force. We'll choose our master and details, and then we will specify our joining condition. Okay. These
Yeah.
are the steps of creating a joiner transformation. You can listen to this video and write it down.
Okay.
So now how do we configure a joiner transformation? Write down.
Okay.
So there is a option in joiner transformation whether we want the comparison to be case sensitive or not. So when
Can you give me
performing,
1 minute, please? Just,
sure,
just give me a minute, please.
sure.
Hold on.
So the master table must be having very good cardinality or uniqueness because this is what happens internally in Informatica. The master table gets loaded in data cache and the detailed tables flows through it row by row.
Mm-hmm.
So let's suppose your master table is department and your detailed table is employee and you are interested in getting department name corresponding to the employee based on the department ID. So you will be joining on department ID only. So
Okay.
all the department IDs will flow through this. It will go one by one in this master table, match the department ID based on hash value and return the corresponding result. Let's say we are interested in department name, so department name will be returned.
Okay.
So it is very important that our master table should be having good cardinality and comparatively lower number of records as compared to detail. That's how we
Okay.
choose our master and detail while using joiner transformation.
Okay.
So we were discussing about what all things we need to configure in our joiner transformation. So first of all, we need to configure whether we need cache sensitive string comparison or not. When performing joins on string columns, the integration service uses this option. By default, it is always checked. Means the comparison is always case sensitive. Okay.
Okay.
Second, like all the other transformations, we can choose the cache directory here where we need to store our caches. Again, we have two types of caches in Joiner, data cache and index cache. Now let's discuss the join types while using a joiner. So when we were discussing SQL, we talked about outer join, full outer join, left outer join, right outer join, full outer join, right?
Yeah. Mm-hmm.
So in Informatica, we will call them normal join, master outer join, detail outer join, or full outer join. Write it down. The join types while using a joiner are normal join, master outer join, detail outer join, and full outer join. So I'll just repeat it. So when we are using master outer join and detail outer join in Informatica, it is exactly opposite of what we use in SQL. If we'll specify that we are using master outer join, then all the rows from detail will be returned. And in case of detailed outer join, all the rows from our master table will get returned.
Uh-huh. Okay.
Next option is tracing level. Uh, Tracing level tells us that what do we want to see in our session log.
Session log. Yes.
I'm repeating this again and again because it is important. We can also define joiner data cache size. So by default it is automatic. but we can change it. We can increase this data cache size in order to improve performance. But it is not recommended to change it drastically and make it a very high value, because ultimately it is going to consume your cache. Similarly, we can also define joiner index cache size, which is size of index cache. By default, it is also automatic, and we can also change this one.
Okay.
Like aggregator, we can also specify whether our input data is in sorted order or not. In order to get better performance from joiner transformation, it is recommended to get the data in sorted order. So if our data is if our data is sorted, we'll check this option that our data is sorted input, and it will add up to performance.
Yeah, but you can check that option in itself in source qualifier, right?
We can do the sorting in source qualifier itself. Then when we are sure that our data which is coming from our sources is sorted, then only we will check this option that our data is sorted.
Okay.
If it is not sorted, we will not check this option. It will revert in error otherwise.
How?
We can also specify transformation scope in our joiner transformation. We can choose the transformation scope as all input or row. So if you'll choose all input, then it will load all the input data into our data cache instead of processing it one by one.
Okay.
Okay. So these are the properties of joiner transformation. Now, when we are using a joiner, we need to specify the join condition. The integration service which does everything for us, whatever we specify, it joins both the input sources based on the based on the join condition that we specify in joiner. So the join condition contains ports from both input sources. Let's say I want to join employee and department table based on department ID. So I will be specifying employee.department ID and department.department ID as our joining condition.
Mm-hmm.
And there is a limitation, we cannot do greater than we cannot do the condition like where a dot salary greater than b dot salary. We cannot perform the joins like that in joiner transformation. We can only specify the equal operator between the join columns. Other operators
Okay.
are not allowed in join condition in joiner in Informatica.
Okay.
Now remind me, what are the join types? What are the join types in joiner?
Full outer join, normal outer.
Normal
I'm sorry,
join?
normal join, master outer join, detail outer join.
Correct. We already discussed about how joins work. Okay.
Mm-hmm.
Now I prepared an example for you. Let's have a look.
Okay.
This is my table item list, which is having ID and fruits. ID and fruits.
Okay.
I know these are not fruits, but
Mm-hmm. That's fine.
let's consider it for example sake. I'll mark it item. Item. Okay. Now in another table, I have mentioned item name and items category. And in another
Okay.
table, I have mentioned the serial number, like here,
And
and the price of that particular item.
okay.
So what if we want to get price corresponding to each item? Then we will be needing a table like this in our result. This will be our result in that case. Okay.
Yeah. Mm-hmm.
So in this case, let's suppose this is my master table and this is my detail table. And the table name is item list. Here the table name is item price. What will be my joining condition? where item list dot id equal to item price dot serial number.
So this will be like a full outer join, right?
This is normal join.
Oh, normal join. Okay.
Yeah,
Okay.
because we are interested in result of inner join where all the values are matching. Okay.
Okay.
So what? Suppose this 1155 is not there in this table. What will be the result of this inner join? This row will not be there corresponding to 11 since it's a inner join. Right? Understood?
Second.
In case of inner join, let's suppose this row is not there. So corresponding to this 11, we will find no match in our item price. So in our result
Uh-huh.
also, the data corresponding to ID equal to 11 will not come.
Yes.
Let's say I prepared this result with everything and I want to join it with product category table and fetch out the name, fetch out the category of that product. Can I do that?
Yes, you can do that.
What will be my joining condition? I am naming this table as R1. So what will be my joining condition? R1 dot item equal to product category dot item will
Uh-huh.
be my joining condition, and it will again be a normal join. Okay.
Yes.
I hope you are clear with joiner transformation now. Do we need more examples? Uh,
No, that's fine.
I'll not write.
That's fine.
I'll not write them down. I'll just dictate them. So let's suppose I have a table called subjects in which I have multiple subjects like math, science, history, ID 1, 2, 3. Then we have a students table with a student and subject ID. Let's say student ID 1, student 1 is reading mathematics. So the subject ID corresponding to 1 will be 1. Student 2 is reading science. So the subject ID will be 2 and so on. Now we can join this table subject and students based on subject ID and fetch the subject name from subjects table. Clear?
Uh-huh.
So in normal join, the joiner transformation outputs only the records that match the join condition and discards all the rows that do not. We are clear with it. Similarly, in
Yes.
master join, in master outer join, the joiner transformation keeps all the records from detail and only the matching rows from master source. It discards the unmatched rows from master source. Like we saw in this case, if we'll do a outer join between item list and item price, I am reviewing this. Let's suppose item list is my master and item price is my detail table. Okay,
Mm-hmm.
and this item, this column ID of this table R1 is coming from item list. So what will happen in case of master outer join? This these values will come corresponding to
Come. Yes.
ID 11.
Yes.
This 55 will come,
11.
but this 11 and hairgel will not come.
I'm sorry?
This 11 and hairgel, whatever the values corresponding to ID 11 were there in our master table will not come. The values which are
Come.
present in our detail table will come.
Come. Yes, that's true.
Yeah. And exactly opposite in case of detail outer join.
GT lateral join.
I will
Yes.
not repeat myself. What will happen in case of full outer join? The full outer join works in similar way as it works in SQL. The full outer join first brings the matching rows from the both sources, and then it also keeps the unmatched records from both master and detail. Okay.
Okay.
Now why do we need sorted input in joiner for achieving performance? Write it down.
Okay.
So we use sorted input option in joiner properties tab when both master and detail are sorted on ports specified in join conditions. We are clear with it. We will make sure that our both the forces are sorted. Then only we will check this option. We can improve performance by using sorted input option as integration service performs the join by minimizing the number of disk IOs. Whenever we perform any operation in any program, the cost is calculated corresponding to the disk IOs it is performing, disk input outputs. So if our inputs are already sorted, it will reduce the number of input outputs on disk, which will in turn increase my performance. So it is very beneficial when we are using large data set. How can we sort the force beforehand? We can either sort it in force qualifier transformation, or we can use sorter transformation to sort both the forces. And we can either sort it in ascending order or descending order, but we have to make sure that both the forces are sorted in same order. Okay?
Okay.
What will happen if my joiner transformation is using unsorted input? So in case of unsorted joiner transformation, the integration service will first read all the master rows before it will start even reading the detail rows. Then the integration service will block the detail source while it caches all the master rows. Then it will read the master rows and unblock the detail rows, and then it will flow one by one, and then we will see our results of join. But in case of sorted joiner transformation, the blocking logic may or may not be possible. In this case, the integration service will use blocking logic if it can दूसरे वाले केस में जब हम sorted joiner transformation यूज करेंगे तो I don't need to sort the input rows, right? Right? Hello?
Yes, yes.
Should I go slow?
No, actually,
So let's talk about performance tuning tips while using joiner transformation. If it is possible, always perform your joins in database itself. Avoid using sorter. Performing joins in database is always faster than performing joins in Informatica session. That is first point. Second point,
okay.
we can improve session performance by configuring the sorted input option.
Okay. Hold on, please.
Another tip is avoid using joiner itself. If our sources are homogeneous, we'll try to perform the joining operation in database itself. It is always faster than using a joiner.
Tell me number 4 again.
The next performance tip is specify the source with as few rows as possible. So whatever rows that we need to take throughout our transformation, we will only mention those rows inside our transformation.
Okay.
And another performance tip is we'll be choosing our master and detail carefully. So the conditions for choosing a master is the source should be having good cardinality and the lowest number of records.
Okay.
So that's about joiner transformation. Now there are some limitations also while using joiner transformation. The first limitation we talked about, that we can only perform the equal to operation.
Mm-hmm.
Another limitation is we cannot use joiner transformation when input pipeline contains a update strategy transformation.
Mm-hmm.
Write it down. We cannot use joiner transformation when input pipeline contains a update strategy transformation. Second, we cannot connect a sequence generator directly to the joiner.
Yes.